Assalamualaikum and hi everyone. So in this video, our group want to present about technique of differentiation. Program CS143, subject MAT183 from group CS143 2A, prepared for Puan Jasmani binti Bidin. So this is the list of our member group. First member, Nur Aina Fatini binti Rodzil. Second member, Nur Humaira binti Fairuz. Third member, Amani binti Saiful Azmi. And the last member is Siti Nur Aisyah Humaira binti Effendi.
Question 1. Explain the meaning of differentiation in mathematics. In mathematics, differentiation is the process of finding the derivative of a function. Geometrically, it represents the instantaneous rate of change of a dependent variable, which is y, with respect to an independent variable, which is x. On a graph, the derivative at the specific point is equal to the gradient, which is slope, of the tangent line to the curve at that point. Then, name the three techniques of the differentiation that you have learned in the syllabus. First is product rule. Product rule is used when the differentiation the product of two functions, which is ux multiplied by vx. Second, question rule. Question rule is used when the differentiation the division of two functions, which is ux over vx. Third, chain rule. Chain rule is used for the differentiation composite function, which is a function inside another function. Moving on to question number 2, we need to differentiate the function equals 5x cubed e to the power of cos x with respect to x. Looking at this expression, we can see it's a product of two distinct functions, an algebra term, which is 5x cubed, and a composite exponential terms, e to the power of cos x. To solve this, we need to apply the product rule. So, step 1, we need to identify the component u and v. First, let's define into two parts. We set u equal to 5x cubed and we let v equal to the e to the power of cos x. Now, we differentiate each part individually. For u, using the power rule, the derivative du over dx is 15x squared. For v, we have to use the chain rule because the exponent is the function itself. The derivative of e to the power of cos x is e to the power of cos x multiplied by the derivative of cos x, which is the negative sine x. So, our dv over dx is negative sine x e to the power of cos x. Next, for step 2, we need to apply the product rule formula. We plug this into the product rule formula, which is v times du dx plus u times dv dx. When we substitute our values, we take e to the power of cos x multiplied by 15x squared. Then plus 5x cubed multiplied by negative sine x e to the power of cos x. This gives us 15x squared e to the power of cos x minus 5x cubed sin x e to the power of cos x. Finish, we simplify the expression by factoring out the greatest common factor. Both terms share 5x squared and e to the power of cos x. When we factor those out, we are left with 3 minus x sin x inside the brackets. So, our final answer is 5x squared e to the power of cos x times 3 minus x sin x.
Question 2b, how to differentiate the function 5x equals log 5x over sin 2x. First, we simplify the logarithm using logarithm law. We know that log a over b equals log a minus log b. So, y equals log 5x minus log sin 2x. Now, expand log 5x. So, y equals log 5 plus log x minus log sin 2x. Now, we differentiate for both sides. dy over dx equals d over dx log 5 plus d over dx log x minus d over dx log sin 2x. For the term 1, d over dx log 5 equals to 0 because log 5 is a constant. For the term 2, d over dx log x equals 1 over x. For the term 3, we use the chain rule. D over dx log sin 2x equals 1 over sin 2x multiply d over dx sin 2x. For the final answer, equals 2 cos 2x over sin 2x. Now we combine and simplify. dy over dx equals 0 plus 1 over x minus 2 cos 2x over sin 2x. We can simplify dy over dx equals 1 over x minus 2 cot 2x. For the final answer, f prime x equals 1 over x minus 2 cot 2x.
So let's move on to question number 3. So the question is, given y sin 2x minus ln 2y equal to 2x squared plus 3. Find dy over dx using implicit differentiation. So I will be explaining how to answer this question using implicit differentiation. First, we need to differentiate both sides with respect to x. Then, for easier step, we can split the equation into 4 terms, which is first term minus second term equal to third term plus fourth term. By doing that, we can differentiate each term individually. So for the first term, y sin 2x, we can differentiate it by using product rule because it involves multiplication of two functions which is y and sin 2x. Here, u equal to y and y equal to sin 2x. The derivative of y is dy over dx because y is an implicit function. So, u prime is dy over dx. Next, we need to find v prime. So we differentiate sin 2x using chain rule. Derivative of sin is cos. Then multiply by derivative of 2x, which is 2. So the derivative becomes 2 cos 2x. So v prime is 2 cos 2x. Now, we need to substitute it into the product rule formula. The derivative of y sin 2x becomes dy over dx sin 2x plus dy cos 2x. Next, we move on to the second term, which is ln 2y. For this part, we need to use chain rule, which is ln u is 1 over 2 times du over dx. So, d over dx ln 2y is equal to 1 over 2y times d over dx 2y. The derivative of 2y is 2 times dy over dx. Therefore, the derivative for the second term is 1 over 2y times 2 times dy over dx. Lastly, we need to simplify it by simply write 1 over y dy over dx. Next, we move on to the right hand side, which is the third term and the fourth term. So for the third term and the fourth term, we can simply use power rule to differentiate it. The derivative of 2x squared is 4x, while the derivative of constant 3 is 0. So the result is 4x. Now, we combine back all the differentiated terms together. dy over dx sin 2x plus 2y cos 2x minus 1 over y dy over dx equal to 4x. Next, we need to collect all terms containing dy over dx to the left hand side. So, dy over dx sin 2x minus 1 over y dy over dx equal to 4x minus 2y cos 2x. Then, we need to factor out the dy over dx. So then, it will be dy over dx in the bracket sin 2x minus 1 over y equal to 4x minus 2y cos 2x. Then, we can finally divide both sides by sin 2x minus 1 over y, so that it can leave dy over dx as a subject. So we can get dy over dx equal to 4x minus 2y cos 2x over sin 2x minus 1 over y. Lastly, we need to simplify the answer by multiplying numerator and denominator by y. Therefore, the final answer is dy over dx equal to 4xy minus 2y squared cos 2x over y sin 2x minus 1.
Now I will explain question number 4 using the differential method. Use linear approximation to estimate the value of fourth root of 15.98 minus 2 over the square root of 15.98 correct to 3 decimal places. First, we will write it as a function f of x equal x to the power of 1 over 4 minus 2x to the power of negative 1 over 2. Next, we find the first derivative, which is f prime x. F prime x equals 1 over 4 x to the power of negative 3 over 4 plus x to the power of negative 3 over 2. Then, we choose a value close to 15.98 that is easy to calculate, which is 16. Now, we find delta x. The formula is delta x equals x minus 8 now. 15.98 minus 16. So, delta x equals negative 0.02. After that, we use the differential formula. Fx is approximately equal to f of x now plus f prime of x now times delta x. Now, we calculate f of 16. The fourth root of 16 minus 2 over the square root of 16 plus 1 over 4 times 16 to the power of negative 3 over 4 plus 16 to the power of negative 3 over 2 times negative 0.02. 3 over 2 plus 3 over 64 times negative 0.02. So the estimated value is 1.499. That's all from us. Thank you.